Okay, we're going to look at an equation of motion that we can derive based on all the information that we've picked up so far. So we've drawn graphs, right? And we have can use the slope of the line to find velocity. We know that. So the position-time equation of motion gives us a position at any time. Okay, if we know initial position and the velocity. Okay. So the equation looks like so. Final position is equal to initial position plus velocity multiplied by time. Final position is equal to initial position plus velocity times time. So there's our first equation of motion that we're going to look at. Now, what this gives us is that when we graph it, we get a nice straight line. If we plot this equation, it's what we get. So our initial position is right here, okay, where time is 0, so where y is 0, that's our initial position. The slope of our line is the velocity, okay, and then that information's all right here. So let's look at this here and see if we can make this all work. So a skateboarder with an initial position of 1.5 meters moves with a constant velocity of 3.0 meters per second. Write the position-time equation for the motion of the skateboarder. So final position is equal to initial position, 1.5, plus 3.0 meters per second multiplied by time. So this is our equation, all right? Initial position plus velocity multiplied by t. Now for b, we want to find the position at time equals 2.5 seconds. So our final position is equal to 1.5 plus 3 times 2.5. And it's a really quick math job here with your calculator. You take 3 times 2.5 to get 7.5, and you add 1.5 to that, and you get 89.0 meters. So after 2.5 seconds, your final position is 9 meters. Okay? So that's how we can make an equation and actually use it. So the equation for a straight line is y equals mx plus b. M is slope, b is the y-intercept. We also could write it solving for y and say y is equal to b plus mx. And this is where it looks like our equation of motion. So y is the same as our final position, right? The variable on the vertical axis. B is the intercept of the y when x is 0. That is our initial position. The slope is going to be our velocity, and then our x-axis is going to be the time. So we can use this equation the same way we use the y equals mx plus b. So slope-intercept equation and also the equation of motion work together. So now some things about position-time graphs. If we have two objects, A and B, traveling along, first off, B starts at 5 meters and is traveling pretty fast. You can find the slope to find the velocity. A starts at 12.5 meters and is traveling a lot slower, a lot lower slope. At some point they're going to meet. B catches A at this point. Okay, the point we could go across and find a position, and we can also find the time. But anytime two lines intersect, then they're in the same location. You and a friend are at the airport hurrying to the gate for your vacation flight to Hawaii. Your friend is well ahead and seems sure to get to the gate first. Just then you spot one of those moving walkways, and you decide, hey, I'm going to hop on this walkway. Your friend is 7.8 meters ahead and walking with a speed of 2.3 meters per second. Your speed on the walkway is 4.20 meters per second. Show that you catch up to your friend at t equals 4.10 s and determine the location the two of you will share at that time. So to start this, let's draw equations. Let's draw an equation for you first, okay? So your final position will be your intercept, which is 0, plus your speed of 4.2 multiplied by t. So getting rid of that pesky 0, 4.2t. Okay? For your friend, we'll draw the equation. Final position is equal to 7.8 plus 2.3 times t. Now we want to prove that we catch up with our friend at 4.10 seconds. So how can we do this? Well, we know the final positions are going to be equal. So we're just going to take our two equations and make them equal to each other. So we're going to say 4.2t is equal to 7.8 plus 2.3t. And then we just do a bunch of algebra. We minus 2.3t from each side and make it equal to 7.8. 1.9t, and then we solve for t. And when we take 7.8, hopefully anyway, if we take 7.8 and divide it by 1.9, we get 4.11 when we round, but we get approximately that answer. So we prove that that's pretty close to happening. Okay, and we know we can find the point where they're going to meet by substituting this number back into the equation for either one, and we can find the meeting point where they're going to meet.